It's working.
Our tonight's presenter is Shellie Luallin, and Shellie is a retired IT professional. She moved from Dallas to Denver in 1998. In Dallas, she had joined the Dallas Paleontological Society, and soon after moving to Denver, she joined WIPS, which is the Western Interior Why am I not able to say that tonight? Shellie is a past president of WIPS and has held other positions such as membership chair, symposium registrar, and field trip leader. For 15 years, Shellie has volunteered at the Denver Museum of Nature and Science. She achieved certification in paleontology, field
I don't have to volunteer at any
specialization,
fucking museum because if they can't figure it out themselves.
and paleontology lab specialization through the museum in 2004. As a museum volunteer, Shellie worked in the Department of Earth Sciences and worked as preparator in molding and casting, and as collections volunteer team lead, and did 3D imaging for them. So with warm welcome, please take the stage, Shellie.
I will do that. Thank you, Catherine. And you were right, John, about how wonderful Catherine is. We've had a delightful time communicating. I've learned some things about her, and she's sent me some fossils to work with. It's been delightful. So let me just tell you a little bit about me. I like humor, as you can see. I wanted to do this about photogrammetry because it's something that you can do. It's something all of us could do. And I think it's important to be able to create these models just for the reactions that you're all having of when you find a fossil, you go out there and you turn around on all sides, looking at those diagnostic features to try to identify it. And reading words, the systematics of a brachipod, isn't always that clear. So having something 3D to look at and turn around in all directions helps you identify those things. So I've had a ball doing this stuff. So the way I found out that you could do it is many years ago, there was a presentation at WIPS, and they showed how you could use this tool to record artifacts. They were doing land features, they were doing archaeological features, and many kinds of analysis of features that are out there. And I wanted to learn how to do that. So they, in 2016, did a workshop at an AMP meeting. And if you've not heard of AMP, that's the Association of Materials and Methods in Paleontology. And they had it in Colorado Springs that year. And prior to that AMP meeting, they had this 2-day workshop where we learned how to create 3D models. Now, I was totally sold. I was going to do it. I was going to do it. So I took that workshop and learned how to make these 3D models, learned how to present them. And I really didn't want to do so much printing as I just wanted to have models where you could see them. So we'll talk about what you can 3D, how to 3D it, and then how to show them. But let me tell you a little bit about the past of this. Okay, you're all familiar with this beautiful thing. This is one that Catherine sent me, and I went ahead and 3D'd it. Mazon Creek fern. Sorry, the zoom. Menu is kind of getting in my way a little bit, so apologies. I'm going to have to go back and forth a little bit on that. So the people who taught that workshop were Nefra Matthews and Brent Breithaupt. Nefra worked for the BLM, and she and some others wrote this technical note, which is, if you want to learn a lot about photogrammetry, this is a really good article. I mean, it tells you what they were doing, how they were doing it, and they were doing it. They were part of the people who were creating the software that allows me to do it. They had input into the product that is now called Metashape that I use. And and the mathematics of it are extreme. I won't go into any of that, but they were using it to manage land. So if I scroll down here and I find a particular piece, got a page 24, they would go out and do close range photogrammetry. That's where they took a series of photographs and they created the models, and they would go back later. And in this image in particular, you can see they'd gone in 2005 and 2006, and then they did the difference between the two. And you can see that this is an area of high impact. It's lost nearly 2 cubic meters of material. So that would be someplace where they would want to go and limit or restrict access to those areas because the land was being damaged too much. There's all kinds of applications for this. It's riverine systems, just the plant life, how it's faring, and so on. But also in this article, if you look at the appendices, they have the really detailed information about the concepts of doing photogrammetry, how to take the good pictures, and so on and so forth. So I did send a list of URLs to be shared with y'all, and it includes this one that happens to be a BLM file that's available. It's a PDF that you can look at and read more about this. But they are the ones who've really been working this through. They used to do these pictures, and they would create 3D models digitally by hand. So they created it. They are a big part of that. And like I said, it's a way to capture things that might someday be lost because they're out there where you can't really collect them, the trackways and so on and so forth. You lose all that valuable information. And you can see, let me see if I can enlarge this a little bit, that the version of the software they're using is a little different from mine. They've got a higher end piece of it than I do. But you can just imagine the studies that you can conduct about the direction of the footprint or the depth of it and the stride and so on and so forth. And one really relevant point that they make in this document is even if you don't have the high-end software or you don't have all the tools that you need, taking the pictures is something then that could be used further down the road. So having the pictures taken this way, the concept never changes. You can in the future use those pictures to study and use in science and documentation of anything really, but paleontologically, you obviously can see it's trace fossils or body fossils or whatever. The software they use and that I'm using is by Agisoft. It's a Russian company. They call it Metashape now. It used to be Photoscan. And Photoscan, or I mean, it's hard for me to remember to call it Metashape. I bought this in 2016 for $179. You can still buy it today for $179, and they update it periodically, and it gets better and better. And it's more my building a model is more successful with this software. It's really fantastic software. So that's the introduction. Let me just catch up, make sure I'm following my sequence here. Let me get my next tab here. I did this in a series of Google. So when I first started out doing this, I hadn't practiced. I didn't know what I was doing, and I wanted to make a 3D model of anything I came across. Well, we happened to be in New York at the American Museum, and I used my cell phone to take pictures through glass. I couldn't get all the way around very well, but this was one of the first models I ever created. And you can see how wonderful it is to be able to sit here in the comfort of your home or wherever you happen to be and see and understand a little bit more about Protoceratops. You don't have to, it's just a phenomenal thing to be able to do that. And the quality of this, of course, isn't great because I was photographing through glass. It's important to do the photography the proper way if you want it to be the clearest and so on. But I thought it turned out pretty dang good. So, oh, hang on. Got too many things going on, I think. It's getting away from that. Let me refresh. So, other uses of it, I happened to go on a field trip to Florida. I don't know if you've ever heard of Montbrook, but the Florida Museum of Natural History and University of Florida have been digging this for quite a long time. It's a Miocene site, and I found turtle and fish, and somebody while I was there found bear, and there happened to be this Gomphothere scapula sitting around, so I took pictures of it. So this is something that if you're on a paleontological dig, it seems like it would be really good to capture photographs so that you can build this and show people how it really was oriented, what the pieces went where, how they were in situ. They've actually used this on one of their blog sites, and they've been creating their own 3D models too. That's really fun and cool to me. Another application is there's a curator at the Denver Museum of Geology who was studying. Now I've done these have been let's see, I published this in 2016, so you can tell it was an early model. Anyway, this is the lichens formation, and it's right at the Permian Triassic boundary, and he was looking for where that might be in actuality, to see if there's some Hangenberg excursion or something like that could tell you when you transition from the Permian to the Triassic. But we went on a field trip, and there was a site that had whatever, it's been a few years, so I can't remember which members it was that he was looking at particularly, but there's these microbiomes that he was very interested in, saying, okay, that what was happening here, is that something that could be an indicator that could be used? So, and then, having a 3D model of it is then something you can discuss this sort of thing with other. And then we have, okay, so earlier, most of you met Steve Jorgensen verbally. He's not shown his video. And as I've mentioned, he has a spectacular collection. I've done 49 models of his collection. I've got many, many more I want to do. But John, here's your cephalopods. We have a few of them here. This is a way to capture this so that many, many people can see these things. I can just click on one here and let it load, and it takes a second. You can examine the sutures, the aperture, shape, et cetera, the nodes, the tubercles, and so on and so forth. It's just a fabulous way to have all this information where you can study it instead of having to go to Steve Jorgensen's house in Highlands Ranch, which is a great place to go, but you can't always do that. So that's some of the early stuff I did. I was just excited to keep on doing 3D. And I've got all the pictures captured and stored in the cloud. So if anybody needs to do more serious work, they can do that. But how did they do that? How did I do these things? So this is where we get into the actual technique. Let me see. Oops, that's not the thing I wanted to pull up. Let me go here. Alrighty. I'm still on the what did I do? How many? This is one of my first of the Steve Jorgensen collection. Is still my favorite 3D model I ever created because the specimen is so fantastic. Now I don't know if you're supposed to say Didymosaurus or Didymosaurus.
Didymosaurus.
Well, in the Latin, there are rules that say differently, but I always call it Didymosaurus, Nebraskaensis.
I got the way to pronounce it from Russo flower, so that was it.
There you go.
This is an interesting one. It's beautiful. It's gorgeous. Uh, and I'm not sure that they figured out why, but they have almost an equal number that twist to the right and then twist to the left.
So you're making me go off on a tangent.
That's
So
beautiful. That's
uh,
beautiful.
a few years ago, there were a couple of guys from Oxford and one from France that were working on mathematical modeling of just that sort of thing, of the twistings and so on. And they actually used this model to compare to the results of the mathematics of how the animal twisted inside to make it turn in whatever direction and how far in that direction it went. So I'm kind of proud of that, um, that little feature. All right, so what you do in general is you take a whole bunch of pictures and you put them in the software. You do a little masking and say, just pay attention to this particular part of the fossil and let it align these photos so it knows how to put it together, and it stitches it together similar in the way we used to do panoramas. But the first thing you have to do is take pictures. So this is from that technical document from the VLM, where the rule of thumb is you have a 2/3 overlap. You want to capture the specimen in this photo and then capture it again this much in this next photo and go all the way across and go in the 90-degree direction. For a lot of different reasons, but you take a lot of photos and then put it in the software to. I have really got to figure out how to move this. Anybody know how to move this little menu at the top? I can't. Hide video panel. Nope, that's not what I wanted to do. There we go. Hide the controls. There we go. Now I just assume that you're seeing what I'm seeing. So this is my setup. I actually no longer use this tent. I mostly do small specimens so they fit on this little turntable. And I can't do this without the menu because I want to show you other things. But you pay attention to the lighting, you pay attention to the settings on the camera. This turntable is a little bit different now. Let me see if I can get that control back because that's crazy. Wow. Don't know how to do it. All right. So if I hold up something, can you see it? Can you see right here that, for example, I have this turntable? Can you see it? Meetings.
Yes, we can.
Okay.
I'm
Thank
sorry, I
you.
was muted.
Yeah. I don't know where the controls are, so they're not in some bottom corner or that is so strange.
Shellie, you are the ones who have taken pictures of my specimens. Yes, I have seen you do this. So, yes.
Okay. Well, what you want to do is have your specimen propped up in the middle of a turntable, and you're going to want to make a 360 loop of it. And so what I did with this turntable, I simply marked this is my beginning and end, and then I marked certain slots all the way around. If you can see those little black lines, that I just turn it that far and take a picture. I usually use a remote for the camera, so there's no shaking from the camera, and go all the way around. I've got different dots so that I know how far I've gone and if something falls over. I use different clays. These are molding and casting clays that I've used to prop up a specimen. So you put that in the middle of it so you can have the specimen up there. For example, if this were my specimen, this is a rudist clam from Texas.
How many pizza pies can you put in your eyes? It's a moray.
So you make a circuit of the specimen, so you've taken all these, but if you only did one circuit, you wouldn't have captured this part or this part. So you need to turn it. And what I have found most successful is to turn it this way about a third of the way and this way about a third of the way. So I make 3 circuits around each object that I put together into to Metashape to create the models. And I use differing colors of clay, you see this object is kind of brown, so there's not a lot of contrast between this clay and the specimen, but there is more with the white, and that's relevant for later when we're processing. But I want to say a few more things about taking the picture. And let me see what I've got here. Oh, let me do this still. So when you're taking a picture, you want to have a consistent focal length. And this is, you take your notes now, because if you're going to you can take pictures and you can send them to someone to process them unless you learn how to do it, or you will have them forever until you learn how to process them. You take them with you would want to do a manual focus because you want to get as much in focus as you can, and you make it so your camera won't change the focus. You want to have a consistent focal length. You want to have the same lighting for each photograph. You want to use the same aperture and f-stop and so on and so forth so the lighting is captured correctly. All those settings need to be the same to get the best that you can in order to create your 3D model. Was there something else I was going to say about that? No. So, I think I was going to start showing, so this is an old picture. It still says photo scan. So, but this is a Didymostros puebloense, these are just pictures that show you how it, is uh, uh, in the software. That's one of the pictures. These are all the pictures, and these pictures show you that down here at the bottom, you can kind of see that I've done different angles of it, but this shows that I've masked off the other parts of the picture because I don't really want my turntable in my model. And so I mask it off to say, don't pay attention to that. This is the series of photos of this object. If you kind of take a look at it, you can see how it's been turned around. You know, you start here, and this is further around, and that little protoconch area, the early part of it, the juvenile part of it, is facing you, and you go all the way around. I actually have the software open with that particular model. And you can see here are all the masks. And with this, there are ways with this tool to select off areas to make it so that it's only paying attention to the object you want. And if I screwed up and this wasn't in focus, I could mask that off because I've got 2 or 3 other pictures that have it covered. There are certain steps that you use to create the model. The first thing you go through, and they've changed this so it's a little hard to see, is you align the photos. Here are all the photos, and they're all aligned. They were all successful. It doesn't really show you too much, but it means that it's found the points in each picture that are key points that they can tie together. If I click on this, you can see these represent the camera position, and you can see where my rings were, how I went around that object. So this ring right here, the perpendicular of that is I can't get it to align. There we go. If I spin around that way, that you can see what the camera was looking at on that particular ring, and that I've got these 3 rings, and I got pretty good coverage of this whole specimen. So you have it aligned. Then you, let's see, you do you load the photos, add masks, align the photos, you do some cleanup. So it's got all these tie points. And this is where it gets a little technical, and I won't go into a whole lot of detail, but the way it calculates these positions of the camera, and it also tries to correct for distortions in the lenses, and that some of that information is in the EXIF, the metadata of photographs that are taken with some of your digital cameras, not so much with iPhone, but or cell phone, but with many cameras that are used for this sort of thing. And mathematically, you can say, okay, for this aspect, get rid of the points that are too far out of whack. They're just, there's too much uncertainty with those points. And there's 3 steps of this that you do, and after each one you say, okay, go back through all the cameras and make sure they're all still aligned properly. It's an optimization process. And you get rid of a bunch of points that way, but they're ones that lead to oddities and artifacts of incorrectness, and you can still see there is a little bit of debris in these around this object. But you have a point cloud. It shows you some of the colors that it picked up from the images, and it's well aligned. And after you've done that cleanup, then you tell it to. So the point cloud it's showing you now is actually tie points. You then build the final point cloud, and then you build the model. And the model is actually, let's see, the wireframe. So it takes all those points and it creates, let's see if I can get zoomed in far enough, you can see the wireframe. So it's got all these faces. They're all triangles, polygons of points. And it's to that wireframe, then it goes back through the pictures and finds the texture that it puts on to each of those faces so that you can see the actual texture of the model. So it creates that wireframe, then you build the texture, and well, wrong one. So that was the model wireframe, and you can see this one's got 600,000 faces. You put the texture on and you've got your final model. Now that's real zoomed in, so all right. Let's see. Oh, right. So if you wanted to learn more about using this tool to create your own 3D, there are a couple places you can go that are really helpful. This fellow has maintained this particular tutorial for a long time, since, well, 2015, I guess. And it's got some really good details about the steps of using Metashape to create your model. He has some other tutorials too about taking the photographs and so on, but this particular part I found is the most useful for keeping up with how to use Metashape. The one thing about it, though, that he's done is he's moved to the pro version. You remember I told you I bought this software in 2016 for $179. There's a pro version. Well, the pro version is $3,500. And so it has some features that you don't have in the standard version. I've not really missed them because I don't know what I'm missing. If you're in an educational institution, you can get it for like $500, provided you follow whatever procedure that Agisoft has for doing that. So this tutorial has some things about the pro version that aren't applicable, but it certainly is still very, very good at helping you through figuring out, okay, my model didn't build right, what do I do next? Or another place is the Digital Atlas of Ancient Life. I don't know if you've heard of this. It's a fabulous place to go to learn things. The Paleontological Research Institute, PRI, in Ithaca maintains this. They're the ones also responsible for the different atlases, like the Cretaceous Atlas and the I can't remember if it's Cenozoic or what they call it, but because I mostly use the Cretaceous Atlas. But these are 2 places. This tutorial with Dinosaur Paleo and Digital Atlas has a lot of really good information to help you figure out how to create your 3D models. All right, so that's how you do it. Again, even if you don't figure out how to do this, taking the pictures of something that may not be available to everyone would be a way to preserve it and extend its accessibility as in 3D. Oh, one thing I forgot to mention, I'm just playing here with my device here, is another really good thing to have in at least some of your photos is a scale. This came from that workshop I mentioned that was way back in 2016. We were primarily doing land. The workshop ended with doing actual objects, but having a scale like this is something that is down to 5 decimal places, 0.20004 meters is the distance between these two spots. You don't have to use anything quite that specific, but if you have a scale in one or more of those, then you have the dimensions captured for someone who's using the professional version, or some other software that is capable of handling that. Um, see if there was anything else I wanted to. Oh, so from this, then you've created your 3D model, and you wanna get them out there where people can see them. Right now, this is just sitting on my computer. So this software allows you to export these models. You can do it in many formats. Um, Export the model. You can see that there are lots of the wavefront object, the OBJ file is if you're in the Microsoft world, the predominant one you would want to use. The STL doesn't come with the actual texture. It's just the vertices, the wireframe. That is commonly used um, to distribute a model for others to study, to create or print. The print primarily printing. I did finally get a 3D printer so I can learn a little bit more about that. It's the STL that you'd want to use because that's the instructions for recreating the shape of the object. Um, it's interesting that you can even do it into an Adobe PDF because you can use Adobe to look at a 3D model and actually physically manipulate it, turn it and pan and zoom and so on and so forth with that. But the last thing that I do is I upload the data. And that's where we get into, once you've created the model and you want to share it to people, you want to put it somewhere where they can see it. And you have to be able to have something that reads this file and shows it to you. It's like having a Word doc, a file.doc that you open with Microsoft Word. Well, there are other things that can read a DOC or other things that can read a PDF. 3D models are a little bit different. And you have to have something that has the ability to allow people to turn it and manipulate it and see it the way you want to. Well, it just so happens that there's this website called Sketchfab, and you can see that every time I go to show you models, I'm going to Sketchfab, and it's free. There are lots of people who've been using it. It's a place that does allow folks to take a look at your models and manipulate them. It's called rendering. I'm not sure this is where I wanted to be just yet on this, so let me go back. Yep, must be. All right, we'll go there. You put them up on a website and people can find them. They can, if you do Google searches, you can find these things. This happens to be the Denver Museum of Nature and Science. They're not using this so much anymore, but these last five models that are here happen to be ones that I created when there was a locality in Colorado Springs called Corral Bluffs, and it has an exposure of the KT boundary. And right after the extinction event, they in the matrix, they are in the strata, they were finding these concretions, and they had these fantastic skulls, and lots of other things. Mostly it was multituberculates, but it was a very exciting find of right after the Cretaceous Paleogene boundary. And I was able to create these models, and they would send it because I'm not sure they had a multi-tuberculate specialist at the museum. And so they would send these models for assistance in identifying what these creatures are. I was so fortunate to be able to participate in that. It was from that find that the NOVA program called Rise of the Mammals was created. None of my stuff was used in that particular thing, but I was able to provide these or make these for them to do the science before the publications happen. So you have this way of rendering. I really like Sketchfab. There are other sites that do this. You need to have something if you want to share your models. You can send the actual model files to people. Some of them can be kind of large if you have a lot of points in your wireframe. You can make it so there aren't so many, but you lose some of the clarity and granulation. I think that was all I was going to say about rendering. I could show you one more thing about Sketchfab though that's really cool is that they have down in the lower right of the model this model inspector. So if I click on that, you can look at other aspects of this model. You can see that they actually Sketchfab let them keep quite a dense wireframe, lots and lots of polygons. Some people try to make it so there are a lot fewer. If you don't need to preserve an incredible amount of detail in the wireframe and make it so the model is more transportable, you can do that because for people to see it, it's this final render that you want to see. And it's the imagery that is projected onto those polygon faces that you really want to see. So you can see more detail with the texture applied than you see with the wireframe itself. And that's a clue about why you want to be thinking about that if you're creating a model, because if you want to print it, you might lose some of those details. I happen to get a printer, and I have a couple of trilobites that I printed. One's a Pacificops and one's a Kynops. They're from the Devonian of Oklahoma. They are different. One of the biggest diagnostic features is the eye, or the compound eye, where this one has I don't know if you can see it, much well, not much larger, but a larger surface area filled with more lenses than this one does, and their cephalon is slightly different, but the detail of these eyes is not preserved with the model. You can see it on Sketchfab with the 3D model and the texture applied, but the actual printing of it, you don't, well, that the technology has a ways to go to preserve that level of detail anyway for printing, because you're only printing little teeny tiny lines of plastic and they're going to lose some of it too. So when you create a model, depending on how portable you want it to be, you might want more wires, more surfaces, more polygons. You might want fewer, but just try it, and it doesn't matter what level you're at. The first time your model builds the way you want it to is so exciting, and it never goes away. I have done hundreds of models, and when one of them, the next one I do, when it succeeds and it looks the way I want it to, it feels so good. I just love doing these 3D models. So, that's enough about making them. It's using them. Again, these were used in the science of that KT site. There are some local geologists who have been documenting the Colorado stratigraphy, and on this particular Cretaceous chart are links to index fossils, and they are 3D models of index fossils that I made for them. I had access to the USGS. The USGS, US Geological Survey, has a facility in North Denver. And up until a few years ago, they had a large collection of Western Interior material. It's not all Western Interior, but A lot of it was, if you've ever heard of Bill Cobbin, and if you've read anything on cephalopods, you have heard about Cretaceous cephalopods, you've heard of Bill Cobbin. His collection was in Denver, and I was allowed access to create these models. It was a joyful time. I created a lot of these, and then it turns out that they needed to get it into a different kind of storage. They were going to move them out of that. It's the purview of the Smithsonian, and they uh, they were working on establishing a location for these specimens to be moved. In the meantime, I had an agreement with them that I could continue making the models, but as long as I gave them all the photos and all the models that I created, I could still put them up on the Sketchfab. So I do have a collection of Smithsonian and USGS fossils on Sketchfab. Another is the Cretaceous Atlas. You know, I mentioned the PRI who created and maintains this. They did link to some of my specimens, but they're kind of removed from the Cretaceous over there in New York. So a couple of models there, and these are actually some pretty fabulous specimens. Let me just click on one of those and it'll download. And oh, you know, I was going to open it on Sketchfab. Let me see if I can do that. Nope, let's not do that. I'll talk about that a little later. But this beauty is a female. Now you can tell from the expanded portion of that fragment cone, and that's a male of it. So wonderful science, wonderful teaching, wonderful learning can be had creating 3D models so you don't have to actually have the specimen in your hand. I just love doing 3D. Oh, so here's the USGS. Again, what I liked to do was get a specimen that was a good example and had good provenance. If you look at any of these models and scroll down just a little bit, you can see that there's information about it. This came from the locality D1927 in Niobrara, and about what size it is. So because I don't have any scale in these pictures, in these models, but you can still see the sutures pretty clearly of this baculites, and that's an identifying feature. There are a lot of baculites species. Don't know which one this is. So there were so many specimens. It was fabulous. And here's the Smithsonian collection. So that's something you can do on Sketchfab, is you can establish collections. So I can go straight to the Smithsonian Institution collection and see the 76 models that I've put in here. I no longer have access to this stuff. It's all in Maryland. This is all I got done for the Smithsonian. But again, this is some of the collection that was used to actually name some of these things. There are some replicas that I created 3D models of type species, or some of them are holotypes, some of them paratypes. But certainly many of them are some of the index species that are used in determining where you are in the strata, the chronostratigraphic, biostratigraphic information. In general, the Sketchfab slash Paleo Girl is me, and I'm happy for people to come waltzing through there and ask any questions about these models. I can tell you one of the most popular models I have, the most viewed, most downloaded or requested, is this direwolf skull replica. It was something at the Denver Museum in the Education Collections Department, and I think I got it up there somewhere around the time Game of Thrones was happening. So it was a pretty popular model. Let me see what else I've got, because I could go off on tangents really easily. So I'm trying to make sure I cover that. I think that's about it. I have some other things I can show you. I would just go on and on. Oh, here's another thing about Sketchfab. Um, uh, I just did a search on Sketchfab, and you can see there are lots and lots and lots of museums. The actual primary user of type of Sketchfab is gamers. They have a lot of creations for the virtual games that they play, but there are a lot of museums doing this I mean, you can see this, they've got 465 models here and 440, the number of models that are out there of things makes it so that things are, one, if the museum burns down like it did in Brazil, you have at least this, and two, I don't have to go all over the world, much as I'd like to do that. I don't have to see some of these artifacts. This Paleo Teaches from Florida. They are teaching students about creating 3D and how to print. I've already shown you the Cretaceous Atlas. The digital atlas of ancient life has a lot of models out there, 600 models that they've been working on to be able to show and help identify and teach about that. And that is my material for this evening. I don't know how to get the menu back to stop sharing. Any questions?
I think
Anybody?
I'm gobsmacked. I think that's wonderful. How long does it take to do? I mean, I know there's probably no such thing as an average model, but how long does it take?
The taking of the photographs, once you have a setup and can put it in place for taking the pictures, really takes a short amount of time. Once you've figured out, okay, I just make these circuits. You get into the software, and it can take an hour or so to get the masking done. I average now about 100 pictures per specimen. And I don't mask them as fully as the Puebloense I showed you. That was in the early days when I thought I had to do every iota. You don't quite have to do that anymore. It's the alignment that takes a while. You go set that to happening and you go walk away, because that takes an hour or two. It depends on how many pictures you have, how dense they are. Yeah, so to create a single model, takes 2 or 3 hours of time. I'm not sitting in front of the computer while it's building. I go do something else, water the plants, pet the cat, that sort of thing.
Yeah, can you show more of your 3D models? Because they are, I mean, even some of your simple ones that they're just amazing at the detail. Like the one I had pointed out the other day, the more I looked at it, the more I kept turning it and seeing more and more. And it was just like, wow.
Are you talking about, which one are you talking about? The Microbacchia?
It was the rock that had all of the different fossils.
Oh, yeah. So this is while I'm here, this is that one. It's, it's a half a cent. It's 6 millimeters by 6 millimeters by 3 millimeters. That's the smallest thing I've done. And you wouldn't be able to print this. The details of these holes in the wireframe are not preserved, but the images laid on top of that wireframe gives you all the detail of that little tiny coral.
And the really cool thing about this particular one is I had asked Shellie when I was talking to her, what is the smallest you've ever done? And it just so happens that this is one of the very tiny little fossils that was on my list to try to identify. And when she showed me this as her smallest one, it was like, bingo, we have a match.
I love it. I totally love it. And this, where did yours come from?
Off the top of my head, I do not remember the box I'm going through right now. I should, and I don't.
Well, this one
It's either
came from
Texas or North Carolina. It's one of those two.
That's interesting how widespread this is, because this came from Maryland. So, and you can see the information down below the model, that tells you. I tried to get at least that much information so people had it. They can localize it a little bit. So, and you wanted to see, let's see, if I go back to Sketchfab to my stuff to collections. I think that was in the Jorgensen collection. So I have, several different areas I've done, Ohio and Florida and Oklahoma, and I'm looking for Jorgensen. There we are. I think it was in here. Yep, there it is. This guy has that Tychodus in it. That one?
So what? Yes.
So this came from the Carlisle Shale in Grant County, South Dakota, and Steve Jorgensen would have to tell you some of the name. This is the Tychodus here. I'm not sure what shark that is. It's a vertebrate, it's just a vertebrate. But it
As
has
you
lots
move,
and lots of pieces of other things in it.
yeah, and as you move around, you start seeing so many other fossils, and it's like, wow, wow.
That is a fun thing. And so you'd have to go to work and identify all those pieces,
Yeah, it's like, to go through that and take that rock apart and find all the, wow, yeah.
Yeah. It's shale though. That would be a challenge. Any other questions?
So, time frame to learn. How much time did it from when you started to where you felt like okay, this is good enough to share, or you felt like you somewhat mastered the process?
Well, you could see that Protoceratops from the American Museum wasn't too great, so I shared before. I was really ready for prime time, but it really didn't take that long. I was working full time at the time, and this is back in 2016. I would do it on weekends or whatever. Uh, so the duration is a lot less than the time span of a few months. I probably had a few hundred hours into it before I became proficient enough that I felt confident I could move on to the next specimen and actually create a 3D model and do it well enough to upload it to Sketchfab.
Yeah. So, Alan, how many of concretions are you going to be sending Shellie to have her do 3D imaging?
And well, my question was going to be, I only joined the meeting about 5 minutes ago, and if she could do it over again, because my granddaughters are here, and so I was, entertaining them. Yeah.
We have
But
a
no, I didn't
recording.
mean, but so I'm not really, as far as to be able to answer that. I've got a bunch that would love to have the 3D models of them, but yeah, I'm not really sure what the procedure was. I didn't see enough of it to know what you guys were talking about.
That's okay. We recorded it. So,
Yes, yeah, and I might need to look that up. Yeah. And I'm sure if there are uh a few that, yeah, I was gonna say, if she's taking volunteers, I could probably have a few that could fit on that list. I don't know.
I'm going
Well,
to stop the recording.
I'm not going to have a whole lot of time to do other people's models.
Mhm.
What my whole goal here is to get you interested enough to start playing with it and figure it out yourself. They do have a trial version of the Metashape software. Take some pictures, take a bunch of pictures, and try it out.
We have a
I'd be happy
question.
to do a little Zoom time with somebody if they wanted to learn how to do it. That way, the more the merrier. I want to see what
Uh,
you got.
Yeah.
We have a question on the chat. Was everything acquired via simple photogrammetry? I cannot say that word.
Photogrammetry?
Yes. Or was LiDAR used?
There was no LiDAR. On the things that I have here, it's all, I sat there with my camera and some sort of a turntable and it took a lot of pictures.
Thank
Really,
you.
really works that way.
What if you wanted to get a picture of like a rock, let's say wall or whatever you want to call it, and sort of be able to image the individual layers of the rock? Like how do you be careful so that you don't make it too big? Because I
That's a really good question.
okay.
So, here's my geology stuff. One of the earliest ones I did was this lichens formation here, and this is they had built a new maintenance building in Golden, Colorado, northwest of Denver, and I took so many pictures. I had to get rid of some of them because I have a 32 gig machine and it couldn't handle it. There was just too much data. So uh, I eliminated some of the pictures. I did it in chunks. So for this piece, this is the orientation of the wall. The building is over to the left here, and so this is like a vertical face that we're looking at that has this exposure of the lichens formation. And let's just see something you can do with this. Oh, there's a falcon member, and let me get rid of that. Pharrell member. Okay, so that's between those two members that James Hagedorn thinks is the Permian Triassic boundary. So I wanted to capture this for further discussion, but so I took pictures horizontally in at least 3 different stripes, and what I then this is a long time ago. I think what I did and what you can do in the software is you can work on a few of them at a time. So if I take the oops, sorry, I clicked. If I take the pictures for this and created a chunk and built it, and then I did these and created a chunk and built it, and take these, then you can join those chunks together in the software. And that's how you do it.
Gotcha.
Huh.
Mm.
But having a lot of memory and a fast processor sounds important, right?
Yeah, it's not the minimum you'd want is 16 gig. Most of the models my all my earlier ones, earliest ones, I had a 16 gig machine and I got so into it I went ahead and sprung for a but this machine's now about 8 years old, so 7 years old, something like that. Anyway, but yeah, the more the merrier. Again, 16 is the minimum you'd want, and that worked very well for me for quite a long time. That's how I learned, is on the 16 gig machine.
Shellie, can you talk a little bit about the difference between this and the LiDAR?
I don't really know LiDAR. Um, I'm assuming that what you're talking about is the something that you can get on your phone.
Yeah.
I've never seen that. I've never used it. I assume it's sort of similar. It's also LiDAR, I think, is similar to those handheld scanners that you can get that for, tens of thousands of dollars. Some museums get those. They're like, I think, they might have come down now, but it's been a couple of years. Oh, it's been like 4 years since I looked at them. They were, $10 to $30,000 for a device that you can just hold over what you wanted to create a 3D and move it around. And it would collect all these points and build it live on the computer with the points that it picked up from those. So I think LiDAR is more similar to that digital scanning than what I'm doing. Because it's creating the points dynamically, whereas this is using photos and picking points and using the pixel size and so on and so forth to create the the model.
We were using, we attended the MTE conference and they were recommending some of these things that are on the cell phones. So I think I've tried Metashape and, oh gosh, I just lost it, Scaniverse. I tried on a cell phone. And pretty simple, you know, it worked out pretty well. You just have to cover all the, make sure you don't have any gaps in what you're doing. So you have to start very systematic and try to keep the light consistent and go all the way around the object and do the next layer and the next, and then make sure you get the top and the bottom. Yeah, they were using them out on sites like you were doing out in open areas, which was a little daunting to be in, you know, looking at a mountain and they're photographing that. But it does a pretty good job, and it for somebody that's just wanting to get their feet wet, it's probably a good way to test it first to see if it's something you want to try to play with. I've got a Mason Creek fossil here. I've got other fossils that I've messed with. I think my bigger problem was excluding the background, not having the background in it that I didn't really need or want in my image. But it did a pretty respectable job without really spending more than 20 minutes playing with it. I really haven't invested any time in it at all, but it did a pretty good job. The only thing I was confused about is like whether you need to get you know, a ruler in there, a scale bar in there, because when I originally did a class with Brett Bredehoft and the people out, you know, from BLM, they were talking about having to put different colored backgrounds on it, and you do this image with a background, and you have to change the background and use this ruler, but make sure you don't get that ruler in it. And it was very complicated compared to what I'm getting off of this, and it gives you a highlight thing and tells you whether you covered all your surfaces or not. Even my dentist is using something similar now to be able to get an impression of your tooth to be able to get a crown, which it's a hard way to, you know, I wouldn't recommend breaking a tooth just to out on this, but no, it's actually the same technology that allowed them to build a 3D model. But yeah, it's just originally when they went through there, they were all about these scale bars and changing the backgrounds and doing this or that, and it was a little more complicated than what I found is happening today. And like you said, the price tag they wanted for the pro version was a big bite, and we're a small foundation, so we weren't going to spend that kind of money unless we were really committed that we were going to sit down and make a process of getting through all of our collection.
Right.
But you can do pretty well with the standard version, I feel, you know, getting these things. I think that's what PRI is using as the standard, unless, well, I assume so. I don't know if they've gone any further now than that.
And I think you can go to Amazon for the turntable, and it's motorized with a remote control.
Oh yeah, I never, I never got that fancy. I do it by hand. This is an $8.99 at Bed Bath and Beyond or something like that is what I did. But yeah, there's a fellow here, Wayne Itano, who built his own little motor to move that, so he can set it for his camera to do time lapse, and he has the motor timed to turn in between the photos that get taken every 2 seconds by the camera. So he can walk away and do the photos, but it doesn't take that long to sit there and turn the turntable and set up. You still have to take the time to set up the
Right.
object to create the circuits of pictures that you want. So just a few minutes to hit the remote to take the pictures doesn't take that long.
Right. I was worried about the turntable moving on me. So I had seen Paul Mayer at the Field Museum was using this motorized thing, and I found it on Amazon. It was really pretty affordable. And you know, works really well. So I've used that. I've had other people coming in here to use the collection, and they've utilized it. And because it's
Nice.
control step by step, it can either be like like an exhibit that's just turning, or it can be something stop, give you a certain length of time, and then move the next stop, the next stop, the next stop. So I actually really liked that, and it was very affordable. So it was not a big expense to put out for that. So I would definitely recommend that. But